Hi everyone, grade 9 students of Luis Y. Ferrer Jr. West National High School. Today we are going to have another instructional video in grade 9 math. And this will be a continuation of our first video for second quarter, still in variation. Now in this video of variation, we are going to help you or guide you on how you're going to answer your learning task for this week. First activity is you have to do learning task 3A. Now to do this activity, let's first have a quick recap on the equation of variation. Since you're going to identify if the given equation is direct, inverse, joint, or combined variation with k as a constant of variation. Let's have a quick recap. Direct variation, your equation should be y is equal to kx, or a variable is multiplied to a constant. Next is inverse variation, y is equal to k over x, or here we are dividing a variable on your constant. Next is joint variation, where we have the equation y is equal to k times q times p times r, or we are multiplying two or more variables on your constant. Next is combined variation, y is equal to k times q times p over r. Here we are combining direct and inverse, wherein on your constant k, you are multiplying q and p, and at the same time, you are also dividing a variable, which is r. Now, I have here several examples on how you're going to answer learning task 3A. Suppose we have number 6, m is equal to k over b. What you are doing is dividing a variable on your constant, and that is when you divide the variable on your constant, it's an inverse variation. Next, number 7, h is equal to k times p times t. Now, we know that if you are multiplying a variable on your constant k, that is direct variation. But if you're multiplying two or more variables, that is already joint variation. So therefore, number 7 is joint variation. Now, number 8 is yt is equal to krm. Now, in this particular example, we cannot say already that this is a variation equation because one part of the equation has two variables. It should be one only. So how do we do that? We have to simplify this first. So next, what you're going to do is divide a value here or a variable to make it one variable on the left side of the equation. So we can divide y on both sides. That way we can cancel variable y on the left side. We'll be left out with t is equal to k r m over y. Now this time, or in this equation already that we have derived, t is equal to k times r times m over y. Now we know that what we are doing on our constant k is multiplying r with m and also dividing with variable y. So therefore, this is an example of combined variation. Okay? So remember, there should only be one variable on the left side of the equation. Now let's go to number 9. Number 9 is y over x is equal to k over k times f. Now at this example, we cannot say right away what type of variation because again, your left side of the equation is not a single variable. So we have to make this first a single variable. Now, how do we do that? Since this is the left side is a fraction, we have to utilize or use cross multiplication, and to do that, you need to have over 1 on the right side so that you can cross multiply. So that's W times 1 gives you W is equal to K times F times X. So that is K times F times X. Now, on this example, we already have one variable on the left side of the equation, which is W, is equal to K times F times X. Now, what we are doing on the constant is multiplying F and X. These are two variables, so we cannot say that it's a direct variation because we already have two variables, F and X, multiplied to your constant K. Therefore, this is a joint variation. So that is how you are going to answer learning task 3A. Now, next activity that you have to accomplish is learning task 3B, wherein you are going to write the equation of variation and solve for the constant of variation. Now, in dealing with this activity, let's have a quick recap on your table of values and your variations. Now, first of all, if we are going to have direct variation, you should have your P values increasing and your Q values also increasing. Now, in this way, your equation can be P is equal to KQ or Q is equal to KP. Titignan lang natin dito kung ano yung mas mataas sa kanilang dalawa. Okay? Later, makikita natin yan sa equation. Next is inverse variation, which where P is increasing and Q is decreasing. Ito naman baliktad. Kung yung isa ay increasing, dapat yung kabila naman ay decreasing. At yung magiging equation natin is P is equal to K over Q. So, P here is increasing. Ayun yung nandito sa left side ng equation. At yung Q naman na decreasing, yun naman yung magiging over natin dun sa constant. Pero, pag ang P mo naman yung decreasing at yung Q naman yung increasing, your equation will be Q is equal to KP. Technically, ang hinahanap lang natin dito, yung pataas, yung dun sa left side ng equation. At yung pababa naman yung Q. Mamaya makikita din natin yan sa example. Now, suppose ganito yung makikita nyo sa given. P values is 8, 11, 14, and 21, and your Q is 48, 66, 84, 126. Now, what do we observe here? Yung P natin ay pataas, 8 papuntang 21, at yung Q natin ay pataas din, 48 to 126. So, what type of equation ito? Ito ay direct variation. Okay. Now, kung meron tayong direct variation, sabi natin, ang equation natin ay pwedeng P is equal to KQ or Q is equal to KP. Depende sa kung ano yung mas mataas. Dito, mas mataas yung Q natin, kaya ang gagamitin natin itong pangalawang equation. Q is equal to K P. There you go. Now, to get the constant, ito na yung ating equation. To get the constant, this is how you're going to do it. So again, Q is equal to K P. Para makuha natin yung constant, isa-substitute natin yung unang values natin, 8 and 48. Yung Q natin ay yung 48. And then, K times yung P natin. Ano yung P natin? Ito, 8. So, what you're going to do, para makuha yung constant, divide lang natin siya both sides by the number na kasama ng k, which is 8. Para ma-cancel yung 8 doon, your k is equal to 6. So that is your constant of variation. So meron ka ng constant, ito naman yung sagot mo sa equation. Next, para lang mag-check natin kung tama ba yung constant of variation natin, gagamitin natin siya dun sa iba pang values natin dito. So that is Q is equal to KP. Q is 66. Is equal to, yung K natin is 6. So, substitute na natin yan. 6 times yung P natin is 11 pag 66. So, let's see. 66 times 6 times 11. So, that is 66. And 6 times 11. Also, 66. So, this is check. Therefore, our constant is really correct. Kasi okay din siya at nag-apply din siya dun sa second value din natin sa table. And so as on the other example. So, that is one example. Now, let's have another example of how you're going to answer this part of your activity. Suppose we have this new table of values. Now, as you can see in this particular example, P value is increasing while your Q value is decreasing. Now, since one value is increasing and the other one is decreasing, definitely it's an inverse variation. But since P is increasing and Q is decreasing, we are going to use this formula. P is equal to K over Q. So our equation, your answer should be P is equal to K over Q. Now that is your equation. Now, we are going to solve for the constant of variation. Since this is the equation, we're going to use this. So, P is equal to K over Q. Isa-substitute lang natin the values from the table. So, P for the first pair, 5 and 12. P is 5, so substitute that. 5 is equal to K. Since we do not know the constant, we leave it as K, and your Q will now be 12. Now in here, to get the value of K, we have to cross multiply. So, lagay tayo ng over 1 sa 5 kasi yun yung whole number. So, that will be K times 1 gives us K, or your constant, is equal to 5 times 12 gives you 60. So, therefore, your K is equal to 60. Let's see if this satisfies the other values on our table. Suppose we have P. For the second one, your P is 10. So that's 10 is equal to K, which is 60. Over Q, which is 6. So that's 6. So 10 is equal to 60 divided by 6 is 10. So that is checked. So we are just actually checking if the value of k is correct. Let's try another one for 12 and 5. So this will be 12 is equal to 60, that's your constant, divided by q, which is 5. And again, 12 is equal to 60 divided by 5, which is 12, which is correct. Therefore, our value of k, which is 60, is correct. So that is how you get the value of the constant of variation. Let's try this last example. I have p 1, 2, 3. Simply, we can tell that's increasing. Your q is 4, 16, and 36. And also, this is increasing. Now, since both are increasing, that is direct variation. Now, since we know that q is the bigger value, therefore, this equation is what we are going to use. Q is equal to KP. So this is your equation. Now let's try to get the constant. Since this is your equation, again, Q is equal to KP. Let's substitute the first pair, 1 and 4. Your Q is 4. So equate that to K times P, which is 1. Now to get the value of K, we divide both sides by the number with K, that's 1. So cancel that. Simply K, or the constant, is equal to 4. All right. Now, since we know that the constant is 4, we have to check if that is correct on the second pair, which is 2 and 16. Let's see. Q is 16 is equal to your K, we computed it as 4, and then multiply to your P, which is 2. But what happens here is that 16 on the left side of the equation equal to 4 times 2 gives you only 8. Therefore, it does not satisfy our equation. How can that be? Let's try to do the last. Let's check it on the last pair. Q is equal to KP. Q is equal to 36. So we'll start with 36 is equal to K computed as 4. So that's 4 times P, which is 3. So that is 36 equal to 4 times 3, which is 12. Again, it doesn't satisfy our equation. Now, what should we do here? Therefore, there is something that we are going to do with the equation to satisfy this. Now, what should we do? We cannot multiply any number with this 4 and 2 and 4 and 3 because we have here also yung sa 1. So what we can do actually here is to square our p. Remember the direct square variation wherein p is squared. What happens here, if that is squared, 1 squared is still 1. So we have no problem with the first pair. Let's try to square this 2. Pag in-square natin yung 2 na yon, so may slash na natin to sa solution. Kasi hindi nga yun yung tamang sagot. Let's try. So this will be 16 is equal to, still, this is 4, para hindi tayo malito. Now, what happens with 2 squared? That is 4. Therefore, 16 pa rin on left side equal to 4 times 4 is 16. Now, this satisfies our checking. Now, let's do it on the other side. Makakancel na to. Kasi mali yan. Gagawin din natin yung ginawa natin sa 2 or value ng p. In-square natin siya. So, this will now be 36 equal to 4 times 3 squared. So, that's 3 times 3 gives you 9. Left side, 36. Now, 4 times 9 is also 36. This now satisfies our equation. Now, therefore, our equation should be Q is equal to KP squared, wherein this is a direct variation pa rin siya, but this is quite special because this is direct square variation. Okay. So that is learning task 3B. Lastly, for learning task 4, you have to solve for the following. Now, you have to apply all your learnings from the first video up to the second video by answering these questions. Now, for you watching this video, I'm going to give you a quite a hint on the first example. The distance from the center of a seesaw varies inversely as the weight of a person. JB weighs 50 kg, sits 3 feet from the fulcrum. How far from the fulcrum must be JP to sit in order to balance with JB if he weighs 35 kg? Now, I'll give you a bit of how you're going to start this. Definitely, you need an equation in every question in learning task 4. But I'll start number 1 for you up so that you'll have some guide. Definitely, the equation will be coming from the first part of the problem. So, ito yan. Definitely, this is an inverse variation because of this keyword inversely. So that is distance or D. Since meron nang nakalagay na variable, mas madali. Di ka na kailangan mag-isip. D na lang. So D varies inversely. Since that inversely gives you an idea that you have to divide something to your K. Kasi pag direct, multiply. Pag inverse, divide as the weight of a person. So that is W. So this will now be your equation for number 1. Next, JB weighs 50 kg. and sits 3 feet from the fulcrum. How far from the fulcrum must JP sit in order to balance with JB who weighs 35 kilogram? Para mas madali, gagawan ko din kayo ng table of values. Ito lang yan. Distance and weight. For the second sentence, you'll get one set, 50 and 3 feet. So, syempre, 50 kilogram is a weight. So, lagay mo dito yung 50. And 3 feet is a distance. So, lagay mo dito yung 3. Next is how far the fulcrum must be to sit in order to balance JB if he weighs 35 kilogram. Wherein the 35 kilogram is also a weight. So, we put that here. And the question is how far should he be from the fulcrum? Then that is your unknown. Ayun yung dapat ninyong isolve. Now, somewhat this is on your example number 1 before or learning task 1. Balikan nyo lang yung video natin last time and you'll be able to answer this. Now, technically, this is how you're going to answer all. Number 2 should be like this also. Ganun din yung step by step. Gawa kayo ng equation, gawa kayo ng ganitong table na simple and then solve for it. Ganun din sa number 3, equation, then solve. Actually, pag may equation na kayo, masasagot yun na yung letter A. And then, while number 4 is a little bit of a logic, think of it very carefully. And while number 5 is something like this also. Give an equation and then represent it with a table of values. And you will not get lost in answering this activity learning task 4. So that is it, grade 9 students, for our instructional video for this week. I hope that you learned a lot. Don't forget to like our official Facebook page, DepEd tayo Luis Y. Ferrer Jr. West National High School, and subscribe to our YouTube channel, DepEd tayo West High. See you again next week. Bye!